This problem is called insert interval, and it has been asked quite a few times in most of the FAANG companies. And in this problem, we have a input list of intervals. So this white intervals denote input, and this blue is also input which we have to insert in this. So this is one list. This is another list with two elements. So any interval will have one start time and one end time. So these all boxes are denoting a interval, and these intervals are non-overlapping. That is, they don't touch each other. There is at least some gap between them, and the new interval that we have to insert in this list can overlap with some of these. So the output should also be non-overlapping intervals. So if it overlaps with some interval, then we will merge them together so that there is no overlap. So let's see how we can solve it. So first of all, there may be multiple scenarios. So again, I will be using this white color to denote the original non-overlapping intervals, and blue is the interval that we have to insert in this, and the result should be a non-overlapping interval. So an easy case would be that there is some gap, and this interval which we want to insert is not overlapping with any of the existing intervals. So the result will be this comes here, and we will return this. There is no overlap. And also let's assume that the input that we will be given will be in this format only. That is, first this will be given, then this, then this. That is in ascending order. Another easy scenario would be that this is after all the intervals have ended. Similarly, it can be in the beginning. So in this case, we don't have to do anything. We will create one output vector. We will start inserting interval by interval. So this interval, insert here. So it comes here. Then the next one, so we can iterate through it. So this will be some vector of size 2, or an int array of size 2, or a list of size 2, depending on the language which you are using. 0 will denote start time, 1 will denote end time in this interval. Next, go to the next interval, copy it. Then this one. Then all the remaining. So this was one easy case. Similarly, these two cases. But there are some scenarios where there will be overlap. So let's take an example. So let's say this is one of the cases where overlap can occur. So this is ending here, and this is starting at exactly the same time. So it's touching each other. So what we will do, we will copy this one. Then these two will merge. So whichever is the minimum starting time, this is the minimum starting time. So it starts here and ends here. So this will form one interval. And then the remaining we will copy as it is and return this. So here it was just touching, but still we consider we will merge them. Next, let's say it starts here and it includes this complete interval and then ends somewhere in between. So again, these three will be merged. So copy this, then minimum is here, starting here, and it ends here. So this entire thing, and then this one, and all the remaining. And there may be different ways in which it's overlapping. It can go even till here, touch this one, then this will also be merged. For example, here it starts here and ends here, but here another interval was starting. So it's touching this one also. So all of these are merged now. So output will have three intervals. This one exactly same, then another one, and this one. So there are multiple ways in which this can overlap. So let's generalize our theory, how we will solve it. So we have a few intervals, okay? And there will be one interval that we want to insert. So what is the general idea? We start traversing this interval list. So what is this input interval list? It's a vector of vector of int. So inner one is one interval having two values, outer one is the list of such intervals, or you can say list of lists. So we start traversing this intervals and we check if the end time, so initially this will be the first interval we are pointing to here. So this is the first interval. We check its end time, that is int 1, and this is new interval ni. So if this is less than ni0, that is it ends before new interval starts, not equal to, because that is the overlap case. So we will insert in the result. So if this is the case, we insert into the result. So result equal to result union this interval. So this means we insert this interval to the result. When this condition will break, when either the new interval touches it, the current interval. So next, once we inserted it, we will come here. This is the variable that we are using to iterate through this list of intervals. Again, its end time int 1 is less than start of this. So again we insert into the result. So these two are now inserted into the result. Now next what will happen? Int will come here. Int is pointing to the third interval. Now we check its end time is less than start time of this or not. It's not. Even if it's equal, we will stop. So we know that we have inserted all the intervals which were occurring before this interval and were not overlapping to the result. And now we will process all the overlapping interval. So result will be just one interval. So we are doing it in three phases. What are the three phases? All intervals, all non-overlapping intervals before new interval. This is the first phase that we have completed till here. Second phase is all overlapping intervals. Intervals are not overlapping, but some of these are overlapping with this new interval. So all of these form one interval, and this together will be inserted as one interval. The start, the minimum among them and maximum among them as one interval. And third phase will be that once we have taken care of this and now this is no longer overlapping with any other interval, this will be the third part. So first and third are very similar. We are just taking this interval and inserting into the result. Taking this interval, inserting into the result. Similarly, these and these. Main part is here. So this loop stops when either this touches the start of this or it's after this start of new interval. In both cases it's overlapping. So we will have two variables, or we will have one interval variable whose 0 will be min of int. Int is the variable which is pointing to this current interval. Int 0 and new I 0. So merged interval, let's call it mi. This will denote this one complete interval mi. So first component will be minimum of this current int or ni, start of both. So this will pick this value. So now mi0 is pointing to this. This is denoting mi0. Now we will check what is the max among these. That will be mi1. So this ni is new interval, mi is merged interval. So mi1 is pointing here. So let me draw it. This is mi1. and we will continue until it no longer merges, it no longer overlaps with ni. So int was pointing here. Next int will point here. Again we will check whether its end time is less than start time of this or not. It's not, so it's merging, overlapping. So again we will check start and end, just end in this case. So end is this one, here end is this one, so pick the maximum. So now mi1 is pointing here, mi1 is updated. So this we will check again and again. So now mi1 is here, and next int will point to this. We will check what is the end time of ni, it's here, and start time of this is here, so it's no longer overlaps. So now insert the remaining. So I hope you understood this, and here we are just making one pass of this list of intervals. So time complexity should be O of n, and we are not using any extra space other than the result that we have to return anyway. So if you count this space, it can be O of n. If you don't count this space, then it will be O of 1. So let's write the code for this. So we are starting the first phase now. So this check should always be there so that I does not go out of bounds. And intervals I, the current interval, this was int here, that this variable I was using. This is nothing but intervals I. So this is intervals 0, this is intervals 1. So you can also use the variable int and put this there. So intervals I1 is less than new interval 0. So end of current interval is less than start of new interval, so it's not overlapping. So what we will do, so this while loop will end when there is overlap, or it may be possible that this new interval was at the end. So then everything will be inserted, then only phase 2 will happen, phase 3 is not required. So this will insert, this will complete the phase 1, this while loop, all the non-overlapping intervals before new interval. Next comes the main part, that is overlapping. Merged interval mi. So let's initialize with new interval. Again, this intervals I means current interval, that is int, that we saw in the explanation. Its start time is less than equal to new intervals end time. Then still we are in the overlapping zone. So this guarantees, this loop, when we come out of this loop, guarantees that we have taken care of all the non-overlapping intervals before new interval. So this is the overlapping zone. Maybe there is no interval overlapping, but if intervals are overlapping, it will start from this current I, because before that everything we have taken care of. So this check denotes overlap. Start of current is less than end of new interval, because if start of current is more than end of new interval, then that means that interval is occurring after the new interval. mi0 will be min of mi0 and current intervals 0. Similarly, So when this loop ends, we will have the merged interval in this min and max. So we push it to the result. And now phase 2 is complete, and we do phase 3, which will be very similar to this. No need to check, there cannot be multiple overlaps. There is just one interval that we need to insert. And here also we need to do plus plus, otherwise this I will remain 0. So pick the intervals I, insert it, and then increment I. So here also we are not increasing the I. So you can do it separately, or here in the last place where we are using I, both are valid. Now this works, so let's submit. And the solution is accepted. And we are here, that is 97%, better than 97% submissions. Now we will do the same thing in Java and Python. And here it's list of integers, so we need to convert it to int array, list to array. And the Java solution is also accepted. Finally, we will do it in Python 3. And the Python solution is also accepted.